Today we are going to start gravitation, correct? It is a small chapter also, and definitely like they ask some of the questions based on particular topics like G values. They will vary the height, they will vary the depth, and they will ask what is the G values, correct? They will ask questions regarding based on total energy, potential energy, orbits, escape velocity, orbital velocity. So we are going to see this, okay? So these are the chapters which are easy chapters. They are going to fetch you marks. So you should focus on these chapters. Mechanical properties of solid. This is a very one of the easiest chapter. Gravitation, correct? Work, energy, and power also. Laws of motion. These kinds of chapters you focus. Okay. So okay, let's start gravitation. So any two objects, suppose we have one object, it is having mass m1 and it is separated by a distance r to another object having mass m2. So they will experience force of attraction or gravitational force of attraction. G means just we name that force of attraction. Every two objects in this universe attract each other, correct? This force is equals to G m1 m2 by r square. m1 m2 mass of the two objects, r is the distance between the two objects, G is gravitational constant. G is gravitational constant 6.67 into 10 power minus 11 Newton meter square per kg square. This is the value of G, correct? So this is the force of attraction between these two objects. For example, try to understand one thing. For example, this object is attracted, this is m1, this is attracted by 10 Newton. Just example I am taking. So this m2 will also be attracted by 10 Newton. Okay. So what I said, any two objects in this universe get attracted towards each other by a force called gravitational force. How we calculate the value of force? This is the formula, G m1 m2 by r square. Now suppose m1 is attracted towards m2 by 10 Newton. So m2 will also be attracted towards m1 by 10 Newton. Some points you have to remember. Means what I am saying, that force on 1 will be same as force on 2. Magnitude. Suppose 10 Newton acts here, 10 Newton will act on this particle also. But direction opposite. This object this side, this object this side. So direction is opposite. But magnitude is same. Second, this force, this gravitational force does not depend upon medium, does not depend upon medium. Means whether the two objects are in the air or these two objects are in the water, their force of attraction will be same. So it does not depend upon medium. Means we are changing from air, we are going from, suppose two balls are there. So correct. Always remember this gravitational force is a central force. Okay. So these points are necessary because they give a statement based question. Okay. So they give statement based questions. So you should remember all these things. That gravitational force is a conservative force. Conservative force. Gravitational force is a central force. Correct. So all these points, these are more important points that the students ignore. That's why I made you write. Okay, conservative force, central force. Okay. Next is, like, suppose someone asks question that, okay, this is a mass m1, this is a mass m2, this force on this mass is suppose whatever f. So suppose here also force should be f, same value. They have asked one question that acceleration of first mass is greater than acceleration of second mass. Acceleration of first mass is equals to acceleration of second mass, and acceleration of first mass is less than acceleration of second mass. Given m2 is greater than m1. What is the answer? Think. Any answer? What is acceleration? See, acceleration is what? Force divided by mass. These things you know now. Force equals to mass into acceleration. Acceleration is force by mass. Force is same for both the objects, but mass is different now. So acceleration will be different. So acceleration of one will be force divided by mass of one. Similarly, acceleration of 2 will be force is same, f divided by mass of 2. Now m2 is more than m1. Means this value is more than this value. So if denominator is more, fraction will be less now. If denominator is more, this whole fraction will be less than this fraction. So a2 will be less than a1, or a1 is greater than a2. This will be the correct answer. Correct. This is more, so this whole fraction will be less. So a2 will be less, a1 will be more. Next. So, like, suppose we have one object like this. This is the earth, suppose. This is the earth. And there is any object on the surface of earth. Its mass is m. Correct? This is earth. There is an object. Suppose I am talking of myself. My mass is m, small m. Mass of the earth is capital M. Radius of the earth is capital R. Suppose. So if I say, acha, this is the earth, what is the center of the earth? This is the center of the earth. If someone asks what is the gravitational force between them, so force G m1 m2, G m1 means suppose mass of earth, m2 my mass divided by distance between them. This is, here I am, this is the center, distance between them is what? Radius. So r square. So this will be the force on me, means force on me, as well as force on earth, same value, G m m by r square. Means earth will attract me. This is the force on mass. Mass m is, small m is what? Me. Force on me, or force on the small mass, is G m m by r square. Means earth will attract me with this much force. Now this value is fixed because G value is fixed, 6.67 into 10 to the minus 11. Mass of earth is also fixed. Radius of earth is also fixed. Means this value is fixed, and we call this small g acceleration due to gravity. Acceleration due to gravity. So finally, this formula becomes small m into G. That's why we take that the force with which the earth attracts is how much? mg. The force with which the earth attracts any object is what? mg. So always remember this is mg. So we are attracted towards the earth. See, we will be attracted in this direction. This earth will be attracted also, but earth is very heavy. It is not going to move. Okay. So any object on the surface of earth is attracted by the force mg. Always remember this G formula. This is very important. G capital M by R square. G equals to Gm by R square. This formula is very important. Correct. Now see, variation of G. Now this is one of the most important topic from which NEET asks variation of G. What is this? That this is earth. On the surface of the earth, I am writing also G on the surface of the earth, its value is around 9.8. Correct? As you go up, G value decreases. As you go down towards the center also, G value decreases. So first consider when we are going up. Suppose we go to a height h. From the surface we are going to a height h. So G at a height h formula, you remember, it is G divided by 1 plus h by r to the whole square. This is G at any height h. If they ask now what is the G value here? G at a height h. So this formula you have to apply. G divided by 1 plus h by r whole square. If this height is very negligible as compared to radius of earth, then what we can write? G at any height h equals to G1 minus 2h by r. This formula. So this formula is very important. If h is less than, very less than r, G equals to 1 minus 2h by r. Similarly, if you go down from the surface of earth, you are going down, suppose to a depth d. At this point they ask, what is G? You are going to a depth d. Here, from the surface of earth, you are going down how much? D distance. They are asking what is the G value. So G at the depth d is G 1 minus d by r, where d is the depth how much you are going down. So G at a depth, here if they ask what is the G value, so G at a depth d is equals to G 1 minus d by r. Always remember, as we go up, G value decreases. Up means from the surface of the earth. From surface. From surface. Similarly, as we go down, G value decreases. till center. Means what I am saying, suppose here G value is 10. If I go here at some height, G value will be, suppose, less than 10, 9.7. G value will decrease. Similarly, if I go down, so G value will become, suppose, 9.6. And here on the center of the earth, always remember G value is 0. Center of the earth, G value will be 0. Again, G value will increase, and here G value will be 10. So follow this pattern, very important. G value here 10. As we go up, G value will decrease. Similarly, you go down, G value will decrease from 10, 9.6. At the center, G value is 0. Now here it will increase because this is the surface now. So see the G value 2, 6, 8, whatever, here G value will be 10. See, G value is 10 on the surface. As we go down, G value is decreasing, and finally it is becoming 0. So always remember, G at the center of earth is 0. Okay, next. Then G formula, one more formula you can write. Constant rho R. What is rho? Density of planet. What is R? Radius of any planet. So this formula is also important. You can see that G value is directly proportional to the density of the planet. G value is also directly proportional to the radius of the planet. Means if a planet has more radius, its G value will be more. If a planet has more density, its G value will be more. G has one more formula. Due to rotation of Earth, what we get? G. G net. G minus omega square R cos square phi. Now what is this? See, we all know that the earth rotates. We all know that the earth rotates. So if the earth is rotating with angular speed omega, then what they say, suppose that this is the equatorial axis of the earth and there is any place which makes an angle phi. Suppose here, example just I am taking, here is India. Example, it makes an angle phi with this equatorial axis. Any country here, they ask what is the G value here. So here it will be G net. And how you will calculate? G net equals to G 9.8 or 10 whatever minus omega square. What is omega? Angular velocity of earth. R, radius of earth. Cos square phi. Phi is this angle. Phi is this angle. Phi is called latitude angle. Means this country is located at what position from the central line? From the equatorial line. Latitude angle. But how? They ask less question from here. But still, anytime they can ask question. So this formula is also okay. We can take. So remember. Next. See. Potential. Potential. So suppose there is any object M. If someone asks that at a distance r, what is the potential at this point? So potential formula is minus Gm by r. This is the formula for potential. They will just ask that here is one mass. Due to this mass, what is the potential at this point? So remember minus Gm by. Correct. They can give after potential energy. This is more important. Potential energy. And this you try to understand. Suppose we have two mass system. This is mass 1. This is mass 2. They are separated by a distance r. They ask what is the potential energy of the system. Always remember potential energy is minus G m1 m2 by r. This is the potential energy of the system. Very important formula. Minus G m1 m2 by r. See, they will ask simple questions only. 30 out of 45, not 30 questions will be direct formula question. But still, little bit you don't understand the concept now. That's why you are not able to solve. Like for example, this I will ask question from this only. Like I explained this, that if we have two mass, what is the potential energy formula? Minus G m1 m2 by r. Now what they will give? They will give like this. They will give like this, that there is earth at a height h, there is mass m, small m. M is the mass of the earth, r is the radius of earth. They will ask what is the potential energy of the system. What you will write? Tell me, potential energy of this system. Two questions. That okay, mass was here and this is the earth. Here you have to tell what is the potential energy. Here you have to tell what is the potential energy. Tell. Direct formula, na? See, potential energy here it will be minus G m m, smaller mass is m, by distance between them. Distance between them is what? This here is this center of the earth is this. Distance between them is what? Capital R. This is the potential energy. Correct? If they ask what is the potential energy here, so minus G m, mass of earth, small m, mass of other object, divided by distance between them. So distance between this mass and this mass is how much? This is h, this is radius of r. So r plus h. Correct? Simple. So sometimes they ask this question also, that initially the object was on the surface of earth and finally we move it to a height h. Initially the object was at surface of earth. And finally we move it to a height h. To a height h. Then find change in potential energy. Like suppose there is an object on the surface of Earth, we move it to a height h. What is the change in potential energy? So change in potential energy means final potential energy minus initial potential energy. Final potential energy minus GMM divided by R plus H. This is final potential energy minus initial potential energy. Initial was minus GMM divided by R. So if you solve this, so this will minus will become plus. So GMM by R. And this is minus. So minus GMM by R plus H. So you can take common G minus GMM. GMM 1 by R minus 1 by R plus H. Now if you solve this, what you will get? See, I am writing here. So GMM R into R plus H, I will take LCM. So this will be R plus H minus R. So it will be GMM R plus H minus R, that is H, divided by R into R plus H. Now since we know that, there is very important point, we know that one point, G equals to Gm by R square. This is very important. So Gm equals to, we can write now Gr square cross multiply. So Gm we can write Gr square H, and Gm we can write Gr square, and one more M is there. Here we have R plus H. So this R and this square is going to be cancelled. So this is MGH, and I divide R numerator and denominator. So it is going to become MGH R by R 1 plus H by R. Now this is very important result. See, proof I have done. What is the conclusion? Conclusion, this is the derivation. Derivation no need to remember, but still I am telling you that if there is one object and you are from the surface of the earth, you are lifting the object to a height h. Then they ask, what is the change in potential energy? So change in potential energy is mgh divided by 1 plus h by r. This is very important. Normally people write only mgh. No, mgh divided by 1 plus h by r. If h is very, very less than r, very small as compared to radius of earth, so this term will be almost zero. So now change in potential energy will become mgh. Like when we lift any object from here to a height h, what we write? Change in potential energy, mgh. Why we write? Because this h, the height we lifted, is very, very small as compared to r. But if someone asks that if you are lifting any object whose height is basically is equals to radius of earth, suppose what they have given in the question, that you have lifted one object whose height is equals to radius of earth, this much height you have lifted, then what is the change in potential energy? What is the answer? So mgh divided by 1 plus h is r by r 1, 1 plus 1, 2, mgh by 2, not mgh. So remember this, very important. Okay. Next we have, like suppose this is Earth. With what speed we should project this object? Suppose there is a ball. With what speed we should project the ball? We should throw the ball so that it does not return back. Correct? It goes out of the field of Earth. The field of the Earth is attracting the ball. So with what speed we should throw so that this ball does not come back? That speed is called escape velocity. That speed is called escape velocity, and its formula you remember, under root 2 gm by small r. Now these are very important things. The small things like student forget. This g, you know, 6.67, and this what? Mass of the Earth. What is r? See, r is from the center of Earth. From what height you are throwing the ball. Suppose you are throwing the ball from here. You are releasing the ball from here, from this level. Okay. So r will be always we calculate from the center of Earth. From the center of Earth, how much distance? This distance is r. This distance is r. So this r we calculate from the center of Earth. Achha, if we are throwing the object from the Earth, surface of Earth, then what will be our small r? Small r, see, all distance always we calculate from the center of Earth. Small r will be equals to capital R. Correct? If we are throwing from this height, some height, suppose this height is h, sometimes they give like this also. So if they ask what is small r, so small r we always calculate from the center of the Earth. From the center of the Earth, this distance from where we are throwing, this distance is r, this is h. So this small r will be r plus h. But if we are throwing from the center of the Earth, small r will be this distance, that is r. So you have to be careful. Escape velocity. Now if you are throwing any object from the surface of Earth, then the escape velocity comes out to be 11.2 kilometer per second from surface of Earth. Means you go ground, go to the ground level, you throw an object with such a speed that it does not come back. What should be the speed? 11.2 kilometer per second. Then we have orbital velocity. What was this? Escape velocity. Then we have orbital velocity, that this is r, means this is Earth, and from the center of the Earth, at a distance r, at a distance small r, there is one satellite which is revolving around the Earth. Then they ask, what is the speed of the satellite? Like suppose this is the speed of the orbital speed of the satellite. So always remember, speed of satellite formula under root gm by, same like escape velocity, but 2 will not be there, under root gm by r. This is the speed of satellite. Speed of satellite. The satellite is orbiting the Earth, means revolving the Earth, around the Earth. Now see, escape velocity we saw, the formula was root 2 gm by r. And you can see the orbital velocity here is root gm by r. So we can say from here the escape velocity is root 2 times orbital velocity. This is also very important. Orbital velocity. So they ask one more question, that this is a satellite, how much time it will take to complete one revolution? How much time it will take to complete one revolution? So always remember, the time taken to complete one revolution, the square of the time period is directly proportional to the r cube. Which if distance of the satellite from the center of the earth is more, it will take more time. So t square is directly proportional to r cube. T is what? Time period of satellite. R is distance of satellite from center of earth. Okay. See, next is, like suppose this is earth and this is any satellite which is revolving around the earth, and this distance from the center of the earth of this satellite, this is a satellite, is r. M is the mass of the earth, r is the radius of the earth. If I ask what is the potential energy of the system, potential energy basic formula we know, minus g m1 m2, that is mass of the earth, m2, suppose this is mass of the satellite, by distance between them, that is r. This is the potential energy of the earth and satellite system. They ask. Other derivations I am not doing. Just remember that the potential energy of the satellite earth system is twice of the total energy of the system. Total energy means kinetic energy plus potential energy. What is total energy? Kinetic plus potential. Again I am writing, what is total energy? Kinetic energy plus potential energy. And what is kinetic energy? Kinetic energy is negative times total energy. Kinetic energy is, see, you remember this formula, you remember this, and you remember this. Kinetic energy is negative times total energy. Correct. Next we have Kepler's law. First law, Kepler's first law. That planets move around the sun in the elliptical path. Normally what we used to think, na, that this is the sun and the planets are moving around the sun in like this circular path. No, this is a wrong concept. Planets move around the sun in elliptical path. So the path is elliptical. This is only the first law. Now this is ellipse. This kind of structure, now this is called ellipse. An ellipse has, see, two axes. This is called major axis of the ellipse. This is called the minor axis of the ellipse. So what they say, the planet is revolving like this. Suppose this is the earth, for example. This is the earth. The earth will go like this, with sun at one of its focus. So sun, you understand, this is sun. Suppose this is sun. And this is earth, for example. This is earth. So sun is fixed here. And the earth or any planet revolves like this in elliptical path. Okay. So this is the first law of Kepler's first law. Second law. Second law. What it says, that when the planet covers equal area in equal time, this is the sun, this is the planet. P means planet, earth, whatever. Suppose in 2 days, for example, in 2 days, this planet moved from here to here in 2 days. Correct? So this is t equal to 0. Here, this is t equals to 2 days. So they calculated this area. Which area? They connected first this point to this point. Now they connected this point to this point. And they were talking about this area. So this is the area. Now again after 2 days, the planet will move further. Suppose here, this is at t equals to 4 days. So what it says, second law, whatever area it has covered in 2 days, same area it will cover in the next 2 days. Same area. Means if I join line like this, correct? So these two area will be same. Suppose this is area 1, this side shaded, this is area 2. So what it says, equal area in equal time, equal area in equal time. This is second law. Again in next 2 days it will go further. Again whatever area it will make will be same. Means rate of area dA by dt will be fixed, constant. How much area divided by how much time? Suppose, for example, 10 meters square area in 2 days. So next 2 days also 10 meters square. So dA by dt is constant and this is equals to L by 2m. What is L? Angular momentum of this planet around the sun. M is the mass of the planet. L is angular momentum of this planet. L is what? Angular momentum around sun, about sun. M is the mass of the planet. Its mass is M. Okay, this is also, they don't ask question. One thing they ask from second law, that always remember angular momentum is conserved. Angular momentum initial equals to angular momentum final. Means wherever the planet goes, where it is here, 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 its angular momentum will always be constant. Its angular momentum is not going to change. Why it is not going to change? Because see, when the planet is at any point, suppose the planet is here, sun is here, so force of them, force of attraction, there will be force of attraction, gravitational. So this force acts along this line. This force acts along this line. Correct? So if I say what is the torque about the sun? Torque about the sun. So there will be no torque because this force acting on this planet is passing through the sun. So if the force passes through the center of rotation, there is no torque. Since there is no torque, angular momentum will be conserved. Torque about the sun is 0. Third law. And most important law, that square of time period is directly proportional to R average cube. Now what is R average? R average is R nearest plus R farthest divided by 2. What is R nearest and R farthest? R nearest means when the planet is nearest to the earth. Suppose the planet, this planet is here. This is the nearest point. Always remember, this is the sun, this is the nearest point. So the distance from the sun, this is R nearest. R nearest. And what is the farthest point? When the planet will go there. This is the R farthest. This distance. See. From here to here, this distance is R farthest. So this is the nearest distance because the planet is near to the sun. And when the planet reaches here, this is the farthest point. So this distance is R farthest. This is R F from here to here. This is R nearest from here to here. What I am saying? T square is directly proportional to R average. R average, R nearest plus R farthest by 2. This is how we are going to calculate. Square of the time period. Time period means how much time the planet takes for one revolution. So the square of the time period is directly proportional to the cube of the R average. This is the most important. You will see a lot of questions regarding this. Okay. The square of the time period of the revolution of the planet is directly proportional to cube of the R average. Achha, one point, last point. When the planet is close to the sun, it moves fast. When the planet is close to the sun, it moves fast. When it is away from the sun, little bit it will become slow. So when the planet is close to sun, when the planet is close to sun, it moves fast. And when it is away from the sun, it will move little bit slow. Means if they ask the speed of the planet, when it is near to the sun, it is high. When it is far from the sun, it will be low. Correct? They ask question from here also. So you solve, see, all the formulas I have given you in one sheet. Next thing is that you have to just solve. Okay, what are the important formulas, how we are going to solve. Anyway, you have to solve the question. Okay, 1 hour definitely I can't solve the question at all. Just concept I am giving, refreshing you the formulas and all. Okay, this is not for explanation and all. Explanation wherever you were there in 1 year, that was sufficient. This is just for revision of points, this point, so that you don't miss. Question also 1 hour we can't do, na? One chapter, 5-6 questions we will do. What will happen with 5-6 questions? We'll have to solve at least 40-50 questions per chapter. This is just revision of concepts. Okay. Okay, we will see tomorrow then with the next chapter. Thank you.